Okay, to clarify what's on the quiz tomorrow, it's only on multiplying and dividing complex numbers, where you multiply the modulus, which is the radii, and you add the angles if you're multiplying. If you're dividing, you divide the modulus and subtract the angles. So if I had one like number 75, in the book, you have 2 cosine 120 plus I sine 120 divided by 4 cosine 40 plus I sine 40. So you're dividing. So your answer is 1/2, and then is your modulus. So you divide these, and then you subtract these, and you have cosine 80 degrees plus I sine 80 degrees and cosine I sine form. And that's how you were allowed to leave that one. If it's an angle that you know, you might go in and write it in A plus BI form only if instructed to. So also I wanted to show you what's going on with some of the rest of them. Like for instance, number 91, these are divided 5/2 plus 2I. And I'm going to write them in complex form first. So this is 5 plus 0I. So if I find the modulus of this one, I have the square root of 5 squared plus 0 squared, which just takes me back to 5 cosine plus I sine. Now to find the angle, this is just out 5 on the x-axis, so I know I'm pointing towards 0. And so I have 0 and 0. On the bottom, if I do the Pythagorean theorem with the square root of 2 squared plus 2 squared, I get the square root of 8, which is 2 root 2, and cosine plus I sine. To find my angle, I'll say tangent of theta is this 2 over this 2, would be my y over x. Tangent theta is 1. Since this is all positive, I know I'm in the first quadrant. So that would be pi over 4 and pi over 4. Now the final answer, if you look in the back of the book, is to actually divide those. And so I'm going to say 5 over 2 root 2, and then I'm going to subtract, and have cosine of 0 minus pi over 4, which is negative pi over 4, plus I sine of 0 minus pi over 4, which is negative pi over 4. Alright, so what they wanted you to do is write the trigonometric forms of the complex numbers, which I did right here, and I did right here, and perform the indicated operation using the standard forms, and check your result of that in part B. Alright, so if I go ahead and work this out, I have 5 over 2 root 2. And by the way, cosine of negative 7 pi over 4, you could get negative pi over 4. You could go coterminal and use 7 pi over 4. But if I find the cosine of negative pi over 4, that'd be root 2 over 2, plus I sine of negative pi over 4 is negative root 2 over 2. And then when I distribute, my square root of 2's cancel out here. I'm going to hit undo though, because I've also got to distribute it over here. So anyway, when I multiply this one, my square root of 2 over 2, and I get 5/4. Then I get plus and negative or minus. When I do this one, my square root of 2's cancel out, and I get 5/4 I for my answer in A plus BI form. And this is in standard or complex form. Now the reason I did this one is also back to your algebra. If we kind of check it as to what's happening, if you can't have a square root on the bottom, which actually I is the square root of negative 1, we multiply by the conjugate. You don't have to do this tomorrow or any time. I'm just showing you what happens. 2 minus 2I. Multiply by the conjugate. That gives me 10 minus 10I. On the bottom I have 4 these will cancel, and then I have minus 2i squared, so I get plus 4. I'm sorry, that's minus 4i squared right there. And so that gives me minus 4i squared, which is plus 4. So I have 10 minus 10i over 8. That means they're both have a common denominator. They're both over 8. And you see if I reduce it, it matches to the answer I got. Alright, so all of that is not required tomorrow. What's required tomorrow is that you know if it's already in complex form, that you know what to do with the r's when you're multiplying and the angles, you add them. If you're dividing and it's already in complex, the trigonometric form of a complex number, then you'll divide the r's and subtract the angles. If they're already in a plus bi form, you'll convert them to the trig form of a complex number and then use the rules that we talked about. So only practice like homework for the quiz will be like homework that was due not this class but last class. Right now, and a couple more examples of what you're doing for tomorrow in case you need more help on that. I may do some of the homework problems, or I may do some around those. Let's do 107. 107 is 1 plus I to the 5th. Alright, so what's really cool is to raise this to the 5th power. It would be like really bad to do this and keep up with it. I don't want to do that. I'd much rather do de Moivre's theorem, which is something I mentioned, I just didn't say the name of it. But if you can write it in trig form, then if you look back on page, I don't really know how to say the man's name, but if you look back on page 448, you've got the theorem that tells you if you have z, which is a number in complex form, to the n power, then you just have r to the n times the cosine of n times theta plus I sine n times theta. So I want to write this in trigonometric form. Alright, so if I find r is the square root of 1 squared plus 1 squared, so the modulus is root 2. And I have cosine I sine. And so I have tangent theta is 1 over 1. And it's all positive, so I know I'm in the first quadrant at pi over 4. Alright, so that's this part. And I'm going to raise all of this using the I don't know how to say his name, theorem, to the 5th power. So all of this is going to the 5th power. So I'm going to say square root of 2 to the 5th power times the cosine, and then you just multiply this, and you get 5 pi over 4 plus I sine of 5 pi over 4. That's it. To raise it to a power, instead of all this multiplication, you just use his theorem. Square root of 2 to the 5th power, you can think of it like this, is 2 to the 1/2 power to the 5th, which is 2 to the 5/2, which means you have 2 to the 2 1/2 power. In other words, you have 2 squared, which is 4, and a square root of 2 left over. Or you can think of it as square root of 2 times itself 5 times. This group gives you a 2 and another 2, so you have 4 root 2. And then times cosine of 5 pi over 4 plus I sine of 5 pi over 4. This is not on your quiz, I'm just talking about the homework. Alright, now looking at the problem on 107, I can't remember what the form they told us to put it in, but we started in a plus bi form, so let's end in a plus bi form. And so if I'd done all of this FOIL, this is what I would get. 4 root 2, the cosine of 5 pi over 4 is negative square root of 2 over 2, plus I, the sine of 5 pi over 4 is negative root 2 over 2. And so when I distribute, the root 2 times root 2 will give me another 2 that'll actually cancel with this 2. And so I just have negative 4. And then when I do that, the same thing happens. I'll get a root 2 times root 2, which gives me a 2, which will cancel with that 2. And so I have minus 4i. And so it's kind of convincing. It's an interesting exercise that we're not going to do right now. Hang on, I was just checking my work. Something's wrong in it. Let me see if I copied it down right. Oh, sorry. I didn't do 107. I actually just did an example for you. 107 was not to the fifth power. This is what would happen, though, if I raised it to the fifth power. Okay, so now let's do 107. Sorry. 107 is 1 plus I to the third power. So I'll have the same modulus and angle on your homework problem. And then I raise all of this to the third power. When I do this, it's just rewriting the number. This is a square root of 2. All right, so you have root 2 times to the third power. Start over. So using de Moivre's theorem, you have that to the third power, so you have root 2 to the third power, which is 2 root 2, and then you have cosine of, sorry, I don't want to confuse you. I need to start completely over, because I shouldn't have the 5 in there yet. Okay, so quickly, to find r, you have a 1 and a 1, so you have root 2. Then you have cosine plus I sine. All right, the angle is pi over 4, because this is all positive in the first quadrant. Okay, now I raise all of that to the third power. All right, so if I have square root of 2 times square root of 2 times square root of 2, I get 2 root 2. And then I'll multiply this and get cosine of 3 pi over 4. So you raise this to the power and then multiply your angle. The reason is like when you're multiplying, you add your angle, so it ended up being added 3 times. Sine of 3 pi over 4. And then if I get it in a plus bi form, the cosine of 3 pi over 4 is negative root 2 over 2. The sine of 3 pi over 4 is positive root 2 over 2. All right, there my 2's cancel and I get negative 2. And here my 2's cancel and I get a positive 2. So if you raise it to the third power, you get negative 2 plus 2i. And this is to go along with the examples that I did in class. Okay, now to do a root problem, that's how you do a power. If you're going to do a root, let's do 137. Okay, so 137. Okay, so you have, I don't want to do 137 because it's too short. All right, I'm just, let's see, 137, 139. All right, let's do 139. 139 is the fourth root of 8 cosine 2 pi over 3 plus I sine of 2 pi over 3. And I'm taking the fourth roots of this. Okay. Now, when we're doing algebra like x to the fourth plus a number or minus a number, either one, by the fundamental theorem of algebra, there are 4 answers. It's just that some of them are imaginary. And now we're actually going to find them. If y'all remind me in class, maybe tomorrow we'll work this one, or one similar to that that has no real roots, but it definitely, so the 2 roots are imaginary, then fall under the bigger complex number system. All right, so what you're going to do first is take the fourth root of 8. All right, the easiest way to do that is make this 8 is 2 to the third, and you're going to raise it to the 1/4 power. So you have 2 to the 3/4 power. So that doesn't reduce, so I just end up with the fourth root of 8. And then you have cosine, and you take your 2 pi over 3, and let me tell you what page you're looking at for the pattern until you learn it. Page 450. Alright, so you take the nth root of the modulus, and then you take your angle and you're dividing it by 4. So right now n is 4. Alright, so you're taking the nth root, the fourth root, and then you're going to divide your angle by 4. So I'm going to say 2 pi over 3 divided by 4 plus I sine of 2 pi over 3 divided by 4. Okay, but that's not enough. If you're doing 4 roots, you have to find 4 of these. Right now I just have 1. So that was my first one, when k is 0. When you have 4 of them, you want to use 0, 1, 2, and 3. 0 means it's just like your first time around in the first quadrant. I'll show you. And then 1 will move you on around and around and around as you go. I'll draw a better picture of it in a minute to show you what I mean. Alright, so this gives me the fourth root of 8, whatever that is. And this gives me the cosine of, if you say 2 pi over 3 times 1/4. That gives you pi over 6. Plus I sine of pi over 6. Alright, so that is my first root. Alright, then the next one, what you're really doing is the formula says to take your angle, take the nth root. We'll erase this right now. That's what the formula says. When you're trying to take the nth root, take the nth root of the modulus, and then you say cosine of the angle plus 2 pi. I think they're using k, which we use a lot, divided into n equal parts, plus I sine of theta plus 2 pi k divided into n equal parts. Alright, right now n is 4. And so I did the fourth root of 8, and n is 4, and right now k is 0. Because what's happening, if k is 0, it's just my first one, then when k is 1, it takes me to the next period, and the next period, and the next period, until you divide them all by 4, and it squishes it back down. So it makes sense. After you do a few, it's hard to get started sometimes. And so this is my first one. In other words, I took my angle 2 pi over 3 that was given to me, and I divided it by 4. Now I'm going to move around a rotation from here. So I'm going to say the fourth root of 8, and I'm going to say the cosine of 2 pi over 3 plus, now I'm going to go 1 over 4 plus I sine, I'm sorry, not 1, plus 2 pi. Right, so this one right here was plus 2 pi times 0, which means you were just going to go through your first cycle. And so this wasn't even here. And now I have 2 pi times 1, and so you have 2 pi over 3 plus 2 pi times 1 divided by 4. It doesn't take long to see that what you're going to add every time is a pi over 2. Because the next one you're going to put in a 2, so you'll go out to 4 pi over 4. But, in fact, I'll go ahead and do it. Alright, so writing my second one a little bit better. This is the cosine, 2 pi over 3 plus 2 pi. If you get a common denominator, is 8 pi over 3, and then divided by 4. If I reduce, I get 2 pi over 3 plus I sine of 2 pi over 3. Alright, so that's the second one. I need 4 of them. The third one is the fourth root of 8 times the cosine of 2 pi over 3, the angle we're given, and right now I'm at the second one. So I filled in 0, 1, and 2. When I fill in 2 to 2 pi k, I get 4 pi over 4 plus I sine of 2 pi over 3 plus 4 pi over 4. So I have the fourth root of 8 times, if you have 2 pi over 3, plus 12 pi over 3 for 4 pi. You get 14 pi over 3, which isn't reduced. You multiply it by 4, and this is 2, and this is 7. So you get 7 pi over 6. Cosine of 7 pi over 6 plus I sine of 7 pi over 6. That's my third one. And I need one more. I'll put in a 3. So I have the fourth root of 8 times the cosine of 2 pi over 3, going back to the beginning, plus 2 pi k. 2 pi times 3 gives you 6 pi, divided by 4. Alright, so if I have 2 pi over 3 plus 6 pi, that's 2 pi over 3 plus 18 pi over 3, which gives me 20 pi over 3, and then multiply it by 1/4, gives me 5 pi over 3. Fourth root of 8 times the cosine of 5 pi over 3 plus I sine of 5 pi over 3. So that's the fourth one. Alright, so here's my answers. The fourth root of 8. That's one number that works. This is another number that works. This is another number that works. And this is another number that works. Let's see, what number was that? 139. Okay, which is exactly what they have in the back. Okay, so I'm going to draw these out. I don't know how long the fourth root of 8 is. But this first one is at pi over 6. The second one is at 2 pi over 3. The third one is at 7 pi over 6. And the fourth one is at 5 pi over 3. And you can see they're 90 degrees apart. It makes a regular polygon, in this case a fourth root, will make a square or a diamond that has the same sides. Okay, now one thing to make this easier is this. Notice all of this stuff when you're going the nth root of r times the cosine of theta plus 2 pi k over n plus I sine of 2 pi k, theta plus 2 pi k. Over n. So you start with your angle, and k is 0. So your first one is theta over n. If you're doing a fifth root, you'll use k is 0, 1, 2, 3, and 4. That's your first cycle, and then second, third, fourth, and fifth. Notice that all of these landed between 0 and 2 pi. Are you gone? Bye, Elena. Okay, so anyway, to know what to add by, if I want to find the fourth root, this is going to end up being 2 pi over 4. 2 pi times 1 over 4 is pi over 2. And so I know that I could do it a little faster if I say 2 pi over 4 times, like this. I have the fourth root of 8, and I have the cosine of the angle. Looking back at the book again, question 139. The angle, the first one was, what was given to me was this. This was my given, 8 cosine of 2 pi over 3 plus I sine of 2 pi over 3. I can get the answers a little faster than all of that work, but you got to explain it the first time. All right, so to do the 4 fourth roots, I have 1, 2, 3, 4. If you do enough of them, you notice that when you're doing that plus 2 pi k over n, if n is the fourth root, you're going to keep adding pi over 2, however many times you need. If you're doing a fifth root, it'll be 2 pi over 5 every time. We might work on it some more tomorrow. But I'm going to start off with the fourth root of 8. And the first one is just plus 0. So I'm going to have cosine of 2 pi over 3 plus I sine of 2 pi over 3. I'm sorry, wrong. Almost messed that up. If you look at the formula, you've got to take your angle that they gave you and divide it into n equal parts. So if I take 2 pi over 3 and divide it by 4 parts, I get my first one, which is pi over 6. So what I just did was I took the angle that was given to me, I divided it by 4, and I got pi over 6, and right now k is 0. Because I'm doing 4 roots, so I have k is 0, 1, 2, and 3. When k is 0, it means you're just doing like your first cycle. All of these are going to have 4th root of 8 in them. Okay. And now to get my other angles without all that work, if I'm doing a 4th root, I'm doing 2 pi k divided by 4 like we did when we changed the period of solving trig equations. And so I'm going to add pi over 2's to the existing angle. So I'm going to take pi over 6 plus pi over 2. Common denominator, pi over 6 plus 3 pi over 6 is 4 pi over 6, which gives me 2 pi over, 4 pi over 6, which gives me 2 pi over 3. So now I'm going to take 2 pi over 3 and add this pi over 2. Pi over 2. So that's going to be 4 pi over 6 plus 3 pi over 6 is 7 pi over 6. You might remember that number. And then to 7 pi over 6, I'm going to add pi over 2. And I have 7 pi over 6 plus 3 pi over 6 is 10 pi over 6, which is 5 pi over 3. So that would be sine of 5 pi over 3. Pi over 3. But if you look back up, this was exactly what I had gotten with all that work up here. So once again, if you're doing 4th root, just take the 4th, divide the angle they gave you by 4, and then start by adding by 2 pi over 4. If you want the 5th root, divide the angle they give you by 5, and then start adding 2 pi over 5 for the other ones that you need. And they'll all land before you get to 2 pi, because it's a lot like when we were solving trig functions and we went out a few rotations or periods, and then when divided, it knocked it all back down and squeezed it to where it needed to be.